Saturn has 146 confirmed moons, and one of them is so physically wrong that scientists spent years checking their instruments before accepting what they were seeing. Iapetus does not just look strange, it looks like two completely different worlds stitched together at the equator, and the explanation took 3 centuries and a spacecraft to finally crack. Iapetus was discovered by Giovanni Cassini in 1671. He immediately noticed something strange. He could only see it on one side of Saturn. When it orbited to the other side, it disappeared. Cassini correctly guessed that one hemisphere must be very dark and the other very bright. He had just found the most extreme brightness contrast of any world in the solar system, a difference so dramatic that the leading hemisphere is about 20 times darker than the trailing one. The dark region, called Cassini Regio, is nearly as black as coal. The bright trailing hemisphere is as white as fresh snow, composed of water ice. No other world in the solar system shows this combination at this scale. The first explanation people reach for is external, dark material from space hitting the leading face. And that contributes. As Iapetus orbits Saturn, its tidally locked leading face sweeps up dust from outer moons, particularly material blasted off Phoebe and other irregular satellites by micrometeorite impacts. That dust is dark reddish-brown, but this is not the complete answer. Cassini mission data revealed a second, more powerful mechanism: thermal segregation. Here is how it works. Dark material absorbs more sunlight and heats up more. When ice and dark material coexist, the dark areas warm enough to sublimate their water ice, which migrates and refreezes on the colder, brighter areas. Over millions of years, this positive feedback loop amplifies tiny initial differences into the extreme contrast observed today. The dark gets darker, the bright gets brighter. A small original difference, driven by physics, became one of the most visually extreme surfaces in the solar system. Then there is the ridge. Running almost exactly along Iapetus's equator is a mountain range that stretches for approximately 1,300 kilometers, with peaks reaching up to 20 kilometers high. That makes them among the tallest mountains in the solar system relative to the body they sit on. They are taller than the Himalayas. They run in a near-perfect line around the equator, and nobody fully agrees on how they got there. Proposed explanations include an ancient ring that collapsed onto the surface when Iapetus was spinning faster, tectonic activity related to the moon's spin-down as it became tidally locked, or convection in the interior pushing material upward. The ring collapse hypothesis is the most discussed, but none of these has been confirmed. The equatorial ridge of Iapetus remains one of the most geologically mysterious features in the solar system. The shape of Iapetus is also wrong. It is not spherical. It bulges significantly at the equator in a way consistent with having spun much faster in the past, essentially a frozen record of its ancient rotation before tidal locking slowed it down. The shape did not relax to a sphere because the interior froze rigid before it could adjust. And Iapetus orbits far from Saturn, at roughly 3.5 million kilometers, more than any other large moon, on an orbit inclined about 15 degrees to Saturn's equatorial plane. That inclination is unusual for a large moon and hints at a different formation history or capture scenario that remains debated. Cassini's flyby of Iapetus in 2007 gave the clearest images and thermal data ever collected. They confirmed the thermal segregation mechanism, revealed the ridge in extraordinary detail, and showed a world that is simultaneously geologically quiet and physically extreme. Saturn has dozens of interesting moons. Enceladus has geysers. Titan has weather. But Iapetus is the one that forced scientists to explain how basic physics, sunlight, sublimation, and orbital mechanics can take a moon and make it look like something that should not exist. Follow for more on the solar system's most extreme worlds, and tell me, the equatorial ridge on Iapetus that may have formed from a collapsed ring, does that explanation satisfy you, or do you think there is something else going on?